In this video, we'll write the net ionic equation for FeNO3 2 plus KOH. This is iron 2 nitrate plus potassium hydroxide. So first, we need to balance the molecular equation. You can see right now I have a nitrate here. I have two of them and only one here. I'm just going to put a 2 in front of the KNO3. That balances the nitrates, but now I have two potassiums. If I put a 2 here, that balances the potassiums. I have two hydroxides, which is fine because I have two here. I have one iron and one iron. That's the balanced molecular equation. Next, we need to write the states for each substance. Nitrates are very soluble if you know your solubility rules. AQ, that's going to dissolve and dissociate. KOH, that's a strong base. That will also dissolve and dissociate into its ions. Even though nitrate here, soluble. But hydroxides, in general, they're insoluble. Unless there's something like potassium hydroxide where potassium's in group 1. But this iron, it's a transition metal. This is going to be insoluble. We're going to write S because it's not going to dissolve. It's going to be a solid. When these two substances react, this goes to the bottom of the test tube in a precipitation reaction. So now we have the states. We can split the strong electrolytes into their ions for the complete ionic equation. Iron, we don't know the ionic charge for iron, but we do know the whole nitrate is 1 minus. Good one to remember. 2 times 1 minus, this has to be 2 plus. So I'll have Fe 2 plus, I'll write the states later, plus 2 of these nitrate ions. Then potassium group 1 on the periodic table. Hydroxides, they're 1 minus, so I have 2 potassium ions. And I also have 2 hydroxide ions. Those are the reactants in our net ionic equation. For the products, we said plus and minus. So again, 2 potassium ions and 2 nitrate ions. And then for the solid here, this iron 2 hydroxide, we don't split that apart. It's a solid. So we just write FeOH2. So this is the complete or total ionic equation. Now we can cross out spectator ions. They're on both sides of this complete ionic equation. They haven't changed, so we're not interested in them. I can see in the reactants, I have 2 of these nitrate ions. Here in the products, I also have 2 nitrate ions. I have 2 potassium ions in the reactants and in the products. And what's left, that's the net ionic equation for FeNO3 2 plus KOH. I'll clean it up, write the states, we'll have our net ionic equation. So this is the balanced net ionic equation for iron 2 nitrate plus potassium hydroxide. You'll note that charge is conserved. We have a 2 plus here, 2 times 1 minus, that's 2 minus. So we have an overall charge of 0. This is neutral. Over here, this is a neutral compound, so net charge is 0 as well. If you count the atoms up, they're balanced too. This is Dr. B with the balanced net ionic equation for FeNO3 2 plus KOH. Thanks for watching.